Hey everyone, hope you had a great day today. We are moving on to lesson 2.3, and for the boys, I have a little bit of a surprise for you when we proceed through the slides. So the explosions are for you boys. Here we go. 2.3, solving multi-step linear equations. So this could have anything that we've talked about so far. They're more complicated. They could include fractions, decimals. We're going to talk about when an equation has an infinite number of solutions and when an equation has no solution at all. All right? So, here we go. Yeah? How'd you like that nice explosion? Yes, here we are. Okay. So, when we're solving a multi-step linear equation, the things you need to process through and ask yourself, 1, do I need to distribute? Do I need to distribute? Okay? Do that first if you have to. Then after distributing, see if you need to combine any like terms. Remember, like terms live on the same side of the equal sign. You add them together and subtract them like we would objects or things. Okay? Once you've done that, do you have variables on both sides of the equation that you need to collect or move to one side? Do that by adding the opposite. This should be very familiar to you. Again, we're going to do another move step if needed. Anything that is living on the same side as the variable term, you want to move to the other side of the equal sign by, again, adding the opposite. Adding the opposite. Finally, we are going to use our techniques from lesson 2.2 to undo the coefficient in front of the variable by multiplication, division, or both. That would mean you could do, if you had like 3/7 as your coefficient, you could do it as multiplying by 7 dividing by 3 in a two-step process like we learned, or you could do it as a single step and multiply by the reciprocal. Finally, check your solution. It'll help you. It'll help you. So go ahead and do that. Oh, I like that. I just have to tell you, I like that. All right, let's see what this is, and let's go through this process. I'm going to change my pen. So, do I have anything to distribute? I got no grouping symbols. Ain't got no grouping symbols. So, we aren't going to distribute, but we're going to combine because, look, I have a 3x and then a negative 2x. Notice how I take this sign right along with that, all right? So, 3x plus a negative 2x is 1x. Then I have 4, a positive 4, minus 7, different signs. I take their difference, that's 3, and then I ask myself, do I have more negatives or more positives? And I have more negatives. Equals 4x plus 3. Okay? Now, I can move my variable to the left or to the right. I know it says left here, but if I move it to the right, my variable stays positive. So let's just go right. It doesn't matter. All right? Let's go right. So I'm going to subtract x. So I have negative 3 is equal to 3x plus 3. Now I'm going to move my constant left. All right? I'm not moving this one. I'm moving this one, the one that's on the same side as my variable. I'm going to subtract 3, and I have, be careful here, because you're going to say, oh, that's 0. That's not 0. That's like having 3 red chips put down. If negative is indicated by red, you put down 3 red chips and you put down 3 more red chips. How many red chips you got? You got 6 red chips, which has a sign of negative 6 is equal to 3x. We're going to undo that coefficient. Here's my coefficient. I'm going to divide. And that says that x is equal to negative 2. Now I'm going to check it. 3 times negative 2 is negative 6 plus 4. Negative 2 times negative 2 is plus 4 minus 7 is equal to 4 times negative 2 is negative 8 plus 3. So, what do I got here? I got 8, 4 plus 4 is 8, and then I got negative 13. So that's negative 5 is equal to negative 5, and that checks. Negative 8 plus 3 is negative 5. All right, why don't you hit pause, try number 2, and I'll do it with you when you come back. All right, welcome back. Sorry, I'm kind of smushed down here. I tried to keep the slides to a minimum, but here we go. I don't see any grouping symbols, so I don't have to distribute. All right, but I do need to combine. I have negative 3 minus negative 3x minus 5x. Those are like things. All right, they're both negative. It's like I have 3 red x-rays and 5 red x-rays. That tells me that I have 8 red x-rays, so that's a negative 8. Now I have negative 6 plus 11. These are different signs. Different signs means I take their difference. That means I subtract. The difference from that is 5. Now I look to see, do I have more negatives or more positives? I have more positives, so that means there's a plus in between them. Is equal to 2x minus 5. Okay? So I'm going to move, in this case, doesn't make any difference. Let's move our variable to the left. Yeah, let's move the variable to the left. I'm going to subtract 2x from both sides. That leaves me a negative 10x plus 5 is equal to a negative 5. Okay? Remember, this is like having 8 red x-rays and somebody giving you 2 more red x-rays. That gives you a total of 10 red x-rays or a negative 10x. Okay? I got to move my constant to the right, so I get a negative 5, negative 5. So that tells me I have negative 10x is equal to negative 10. These go away. All right? I'm going to undo my coefficient. So I'm going to divide by negative 10, and that tells me that I have x is equal to 1. There is my answer. How about negative 1? How about that? All right, negative 1. No, because that's a negative 10. Sorry. X is equal to a positive 1. Negative 10 divided by negative 10. Negative 10 divided by negative 10. So x has to equal 1. To check it, you plug it in. So I have 3 times negative 1, that's negative 3, minus 5 times 1, that's minus 5, minus 6 plus 11, equals, sorry, I'm getting smashed. Then I'm going to get what? 2 minus 5, all right? Looky here, I got a positive 11. These two add to a negative 11, so I'm ending up with negative 3 equals negative 3, and it checks. Okay? It's only going to give yourself strength if you check. I understand it takes some time, but let's check as much as we possibly can. How about that explosion? All right. So let's look through this one. I have 11 plus 3 times, in parentheses, a plus 1 equals 5a plus 6. Look, I have a grouping symbol. I'm going to highlight my grouping symbol for you right here. This means that I have to distribute. All right? I have to distribute. So let's do that first. I have 11 plus 3a plus 3. Please don't forget this one. That's where most errors occur. You don't distribute across everything. This is 3 times a plus 3 times 1. All right, is equal to 5a plus 16. All right, I have a few like terms that I can combine. I have an 11 and a 3, so I get 14 plus 3a equals 5a plus 16. All right, I'm going to move my variables to the right so I can keep them positive just because I feel like it. So I'm going to subtract 3a. Okay. And that leaves me 14 is equal to 2a plus 16. Now I have to move this constant to the right, to the left, all right, by subtracting. And I get 2a, negative 2 is equal to 2a. These go out. And I take their difference because these are different signs, which is 2. And then I have more negatives. This is a negative 16, so I have more negatives. Now I divide by my coefficient, and I get a is equal to a negative 1. And then I check it. So to check, I go 11 plus 3 times negative 1 plus 1 is equal to 5 times negative 1 plus 16, right? This is 11 plus, this is 0. So that means 11 plus 0 is equal to negative 5 plus 16. Notice how I'm keeping each side separate, and I'm simplifying each side separately. So I get 11 is equal to 11, and it checks. Very nice? Very nice. Ready? Here we go. Woohoo! All right. You try number 4, put it on pause, and see what you get at the end. All right, welcome back. I see grouping symbols. I see grouping symbols. So that means that I have to distribute. So here we go. When I distribute, I get 4k. I'm not going to forget to distribute to that negative 3. Minus 12. Minus k equals k minus 6. Please don't forget. Please, please, please. All right. I got like things to combine. Here's my equal sign. I got 4 kites and a negative 1 kite. I got opposite signs, so I have to take their difference. I have different signs, so I take their difference. That's 3k. Now I got to pick my sign. What do I have more of? Do I have more positives or more negatives? Well, I have more positives, so that becomes a positive 3k minus 12. That sign is optional. Is equal to k minus 6. All right? I'm going to move my variable to the left. All right? So that means I'm going to take this k and I'm going to subtract it so that I get rid of it over there. And I'm left with 2k minus 12. This is like having 3 kites and giving 1 kite away. That leaves you 2 kites. These are gone. All right, now I'm going to move my constant to the right. I'm going to add the opposite of 12. And I have 2k is equal to, okay, be careful here. I have negative 6 plus 12. I have different signs, so I take their difference. Difference means I subtract. 12 minus 6 is 6. Now, what do I have the most of? I have 12 positives and 6 negatives. I have more positives, so this has to be a positive 6. Then I'm going to divide by 2. K is equal to 3. Now I'm going to check it. All right? So here we go. Here's our check. 4 times, oh, there's a K. I'm going to plug in a 3 minus 3 minus, here's another K. 3 is equal to 3 minus 6. 3 minus 3 is 0. 4 times 0 is 0. 0 minus 3 is equal to negative 3. This is 3 minus 6. So this is like different signs, take their difference. I got more negatives. All right? 0 minus 3 is negative 3 equals negative 3. And it checks. All right. Here we go. Again, we're solving for x. We have distribution on both sides. Anytime I see this parentheses situation, grouping symbols, could be a bracket, could be a square bracket, could be a squiggly bracket, could be even a big division sign, right? Means I have to distribute. Okay, here we go. I'm going to take 4 times 8. That gives me 32 minus 4 times 3t, 12t. 3 times 4, don't forget this term, otherwise you will get an incorrect answer, is equal to 32 minus 8t minus 16. Negative 8 times 2 is a negative 16. All right, I don't have anything to combine over here, but I do here. I have 32 minus 16. All right, so that means I have 16 minus 8t. And over here I have 32 minus 12t. What do we want to do? Let's move this to the right. Even though this is left, let's move our variable to the right. And we'll get a positive coefficient. Okay? And this will be to the left. Okay, it doesn't matter. It doesn't matter, whichever you're more comfortable with. I'm just trying to do a mixture of both to meet both needs. Okay? If I want to move this negative 12t over here, I must add its opposite. Remember, start thinking of subtraction as adding the opposite. When I do that, I get 32 is equal to 16. Look here, I have different signs, so I take their difference. That gives me 4t. Now, do I have more positives or more negatives? Well, I have more positives there. Okay. Now, I want to undo this 16 right here. I have to move any constants away from my variable term, so I want to move 16 here. And I get 16 is equal to 4t. And then I'm going to divide by 4. And I get t is equal to 4. And then I check it. I get 4 times 8 minus 4 times 3 is 12 is equal to 32 minus 8 times 4 plus 2. This is 4, negative 4, right? So 4 times negative 4, that's a times. So it might get loud in here. People just came in my house, so just bear with me. The dog might bark. And 32 minus 48. 4 plus 2 is 6. 6 times 8 is 48. This side simplifies to negative 16. And I'm going to take the difference here. That's 16. And I'm going to see, do I have more negatives or do I have more positives? I have more negatives, and it checks. All right. We just keep moving along. This one has a fraction. So let's clear the denominator and get rid of the denominator in the very beginning. Then we don't have to worry about it. What's my least common denominator? 2, 3, or 6, or something else? Well, 2 goes evenly into 6. 3 goes evenly into 6. So 6 has to be my common denominator. I'm going to multiply everything by 6. And I mean everything. Every single term. Do not forget every single term. Kind of like what we have to do with distribution. All right? So 6 times 2 is 12. 12 divided by 3 is 4x. All right? 6 times 1/2. I can do it the way I just did this one, or I can say, 2 goes into 6 3 times, and I'm left with a negative 3x. These cancel, and I'm left with negative 1x, and 6 times 2 is negative 12. I have some things to combine. I have 4x and 3x. They're different signs, okay? So that means I'm going to take their difference, and I'm going to use the sign that I have the most of. I have the most positives. Negative 1x minus 12. Now I have to move all the variables to the left, so I'm going to add 1x That gives me 2x is equal to negative 12. And I'm going to divide by 2. I don't have to move the constant because when I move my variable, my constant ends up all by itself. So now I'm undoing my coefficient. And x is equal to negative 6. And check it. Check it, check it, check it. Go into your original. 2/3 times a negative 6 minus 1/2 times a negative 6 equals negative 1/6 times a negative 6 minus 2. Okay? This becomes negative 4 plus 3 is equal to, this becomes a positive 1 minus 2. So negative 1 equals negative 1, and it checks. Notice in the checking, I simplify the left side and I simplify the right side. And my goal is at the very end, when I get each side down to a single number, that's the same number. That's the goal. All right, try number 7. Come back, hit pause, come back, and see if you got it right. Okay, here we go. I got a bunch of numbers here. Check to see if your smaller numbers go evenly into your biggest number. 2, yes. 3, yes. 4, yes. So 12 is my magic number. 12, 12, 12, 12. I got to make sure I do each and every term. Don't miss that point. All right? All right? So 3 goes into 12 4 times, so I have 4x. This 12 cancels with this 12 minus 5x. 4 goes into 12 3 times, so 3 times 3 is 9. 2 goes into 12 6 times, so 6 times 1 is 6x. All right? I can combine. All right? I have different signs, so I take their difference, which means I subtract. Difference means subtract. So 5 minus 4 is 1. Now, what do I have the most of? Do I have more negatives or do I have more positives? Look, I have more negatives. So that's a negative 1x is equal to 9 plus 6x. I'm going to move my variable to the right, just because I can. I'm going to move my constant to the left. Right? If I move my variable to the right, I get 0 is equal to 9 plus 7x. Now I'm going to subtract 9. And I get negative 9 is equal to 7x. Divide by 7. And x is equal to a negative 9/7. This one's going to be trickier to check, but we can do it. We can do it. But I don't think I have enough space. So you know what? I'm going to check this one in class when I have more room to work with. All right? Please ask me to check it. All right. Just like we clear out our denominator, sometimes it's easier when we have decimals to multiply by, in this case, 100 to get rid of our decimals, okay? So I'm going to multiply by 100 each time, right? So 0.1 times 100 is going to give me 10t. 0.05 times 100 gives me 5. But I still have this grouping symbol. And then 100 times 0.09 gives me 9 times 20. Right? Now I'm going to distribute. So I have 10t plus 100 minus 5t equals 180. I'm going to combine. I have different signs, so I take their difference. Difference means subtraction. Hopefully you're understanding that. So this is 5t plus 100 equals 180, right? I don't need to move my variable. I only have one. Don't worry about that one, right? I need to move my constant to the right, so I'm going to subtract 100. So I get 5t is equal to 80. Then I'm going to divide by 5. And I get 15 is 75, 16. T is equal to 16. 16. And then we're going to check it. So I have 0.1 times 16 plus 0.05 times 20 minus 16 equals 0.09 times 20. Then I get 0.16 plus 0.5 times 4 equals 0.2. And then I get 0.09 times 20 is equal to 1.8. And this should be not 0.16. I'm sorry, this should be 1.6. My bad. Right? So this, when I add these together, I get 1.8 is equal to 1.8. Squeeze that check in there, didn't I? Here's my solution. Here's my check. We're getting close. Maybe we're done. Okay, infinite solution. All right. You approach the problem the same. When you end up with a certain thing and you can't go any further, I'm going to describe the certain thing. This is when you know you have infinite solutions. So go about your business solving just like you would. I see a grouping symbol, so that means I have to distribute, right? So I get 5x minus 15 is equal to 5x minus 15, right? Now, we could stop here because we have the exact same thing. Those of you, this is the reflexive property. Something always equals itself. No matter what we plug in for x, we're going to get the same answer on the same on each side because we're going to multiply by 5 and then subtract 15. But let's just say you didn't notice that, all right? Let's move our variables to the left. I don't have anything to combine, so we'll move our variables to the left. And I get negative 15 is equal to negative 15. And I get 0x here. Now let's add 15 here, if we just stay with it. And I get 0x is equal to 0. All right? So no matter what I put in for x, if I multiply it by 0, my answer is always going to be 0 because that is the multiplication property of 0. Okay? So whenever you end up with a situation like this, or 15 equals 15, or negative 15 equals negative 15, or here, you can recognize it at any level during the process. That means that you have infinite solutions. Infinite solutions. All right, let's do an example and show you what it looks like when you're going to end up with no solutions. Again, you proceed just like you would, all right? I got a grouping symbol. So I got to distribute. Okay? Here we go. I get 2x plus 3x plus 3 is equal to 5x plus 4. 2x plus 3x is 5x plus 3 is equal to 5x plus 4. All right? Now, at this level, if you look at it, if I take a number and I multiply it by 5 and then I add 3, am I ever going to get the same answer as when I take that same number, multiply it by 5 and add 4? No. All right. But if that's not intuitive to you, move your variable to the left. Okay. So I have 0x plus 3 is equal to 4. Move the constant to the right. And when this says that 0x is equal to 1. Okay? Now watch what happens. Whatever I plug in for x, if I multiply it by 0, I'm never ever going to get a 1, am I? No, because 0 times anything is always going to be 0. So there's never going to be anything I can plug in for x. 0 times x is never going to equal 1. This should be a 1, sorry. Okay? All right? So what we say is there is no solution. And we use this symbol. Right? Yay! All right. We are going to work on day 1 tomorrow in class. Come prepared. Thanks for listening. You guys are doing a great job. I will talk to you soon.